Arctic terns have stubby legs, so they're clumsy on land. But in the sky, that's a different story.
It's a very elegant bird in the air. This is really a bird that's made for life in the sky.
And, says Carsten Eggevang, a researcher at the Greenland Institute of Natural Resources, Arctic terns put that flying ability to good use.
It conducts this extremely long migration.
A migration from the Arctic to the Antarctic and back. Arctic tern. Arctic terns have stubby legs, so they're clumsy on land. But in the sky, that's a different story.
It's a very elegant bird in the air. This is really a bird that's made for life in the sky.
And, says Carsten Eggevang, a researcher at the Greenland Institute of Natural Resources, Arctic terns put that flying ability to good use.
It conducts this extremely long migration.
A migration from the Arctic to the Antarctic and back every year. The birds fly across an incredible amount of our planet, and Eggevang wanted to know more about that journey, how they get from the very north to the very south, and where they stop along the way. So in July of 2007, Eggevang headed up to Sand Island off the coast of Greenland, right here. That's where he could find 1,000 breeding pairs of Arctic terns. His plan was to attach little geolocator bracelets to the legs of the birds to log their flight paths, but that was easier said than done.
The island we worked on is a very flat island in the middle of a big fjord, so there was absolutely no protection towards storms. So we had some really bad weather where our tents blew into the sea.
Wait, your tents blew into the sea? Didn't you need those tents to sleep?
Yeah, they were dead. Just devastated by the storms.
And if the cold and wet weren't enough, and the noise, they were also under attack.
The Arctic terns are very good at defending their colony, so they would attack us all the time from behind where you didn't notice them. The ears and the head with their really pointy beaks.
And yet, despite the frosty elements and getting hammered in the back of the head over and over again by the very birds he was trying to study, Eggevang was able to set up a handful of traps.
Extremely simple but rather effective trap that we would place over the nest. And once the bird comes back to incubate the eggs, the trap will catch the bird and we're able to handle the bird.
Eggevang managed to trap 50 Arctic terns and attach the bracelets to them. And within days, the birds took off in small flocks of 10 to 20 and began their migratory odyssey. To retrieve the data, Eggevang had to get those geolocators back. So he waited a whole year for the birds to return. And when they did,
we had to find the exact same individual that we marked the year before.
How did you find the birds again? You would look with binoculars in the sky?
We would look up in the air at several hundred birds at the same time and look for that one bird that would have a small mark on the leg. So that was really time consuming.
Eggevang would track the bird back to its nest and set up that same trap to retrieve his geolocator.
Well, we are really far away into the Greenland wilderness, so we don't have all that much to celebrate with, apart from a bottle of whiskey. So we had a whiskey when we caught a bird.
All told, he tagged 10 birds and drank 10 shots of whiskey. In a moment, we'll track 2 of the birds that he tagged. And if you look in the upper left of your screen, you can match their migrations with a moving timeline. He expected to find the birds would be in a hurry to get where they were going. But after leaving the breeding grounds, the birds spent a month hanging out in the middle of the North Atlantic.
This was completely unknown that the birds would do that.
Most of what's driving their migratory path is food, so they hang around spots where there are lots of small fish to eat, like this part of the Atlantic. They start flying south again in September.
And then something really surprising happening around equator.
There's a migratory divide, a split.
About half the bird would follow the coast of Africa, whereas the other half would cross the Atlantic and then follow the coast of South America. But even though the birds would be scattered all over the Atlantic Ocean, all of them came back to spend the winter in the Weddell Sea down at Antarctica, where they will find an iceberg and rest and just fish and eat throughout the winter.
From November to April. And then within a week, all the birds take off to begin their northward return flight.
Instead of following the same routes as they did when they migrated south, they would pick a totally different S-shaped pattern, flying towards Africa, crossing the equator around the 1st of May, and then reaching almost as far as the Caribbean before they would start flying towards Greenland.
The birds were able to take advantage of a strong tailwind by taking this particular path, so they covered a lot of ground, over 300 miles per day.
It's like the birds were in a hurry to get back to the breeding grounds, and they more or less just went as fast as they could.
Here you can see the tracks from the birds that Eggevang tagged. He can say something now about hotspots in the ocean, places that are especially rich in food, not just for Arctic terns, but for other seabirds and marine mammals too. That can be helpful in deciding which parts of the ocean require extra conservation attention. And Eggevang has calculated that all the flying an Arctic tern does during its life.
It's equal to if the Arctic terns were to fly to the moon and back 3 times. That's really amazing if you look at it that way.
What's amazing to me is that the birds they're spending time in polar regions and temperate regions and equatorial regions and different temperatures. They really have to be adapted to the whole globe.
That's true.
So do you have kind of a new respect for these birds after seeing the results?
Yeah, absolutely. I mean, they are really, really tough small birds.
And because of where Arctic terns spend their time, says Eggevang, in a year they not only see more of our planet, but also more daylight than any other creature on Earth.
Was that menu of yours entirely Google Earth, or was there additional stuff?
There's a KML version of it, so you can play it back right in Google Earth and pause it and zoom into places that you
So if you're interested in touring, I urge you to go to our touring tutorial where Karen showed you on the website, and it's step by step on how to create your tours. Thank you. Hand it off to
Welcome back, everyone. Hope you all had a good lunch. It's good?
Yep.
Yeah. All right. So I'll take you now through the 2 different applications that use Earth Engine. These are both applications that we've written to help people use the system. The first one is publicly available now. It's at earthengine.google.org. And it is our our sort of data catalog. And then the other one is advanced usage of this, which we'll go to in a second. So what I'm going to do is I'm going to quickly go through an example of using this site to look at our catalog, and then I'll take you through step-by-step hands-on. So I'll go through it quickly first to give you a sense of just what I'm doing, and then we'll go through it more slowly together. So the idea is that at earthengine.google.org, you have access to all the imagery that we've been downloading, and you also have access to some maps, some featured maps that we've made with our partners. So I'm not going to go into those maps that they're down here. There's some pretty nice ones. The Mexico one that I showed is in here. You can navigate that. The time lapse where you could zoom in and out and see things change over time is in there. So there are lots of good examples of maps built with Earth Engine here. But what I'm going to show you is how to navigate the data catalog to look at some imagery. And we're actually going to do a little bit of a change detection, with this. So this is the home page. The data catalog is where you can find lots of the different types of imagery that we have. So you can search for data sets, but we also have popular ones listed here. There's MODIS data, which is daily. There's Landsat data, which is higher resolution. And then there are many other kinds of data sets. SRTM is DEM to see elevation. But what we're going to do is we're going to look at this MODIS data set. So this MODIS data set is a 16-day composite that's been adjusted to deal with the different angles of the sun. So when you click, so here we are in the data catalog, which I got to by clicking here. If you click on the description of the data set, you get a page like this, which says what the data set is and who provided it and the times that we have for it. So so different satellites have been up in the sky and distributing information during different time spans. So this one we have data from the beginning of February 2000, and then we actually have all the data, the most recent data too, it's just not written down here. So that shows you kind of what the data set is. If you want to look at that data set, you can open it in the workspace here. So that opens it up into this workspace, which is this tab. So you can go back and forth between the data catalog and the workspace by using these. Now, MODIS is a global data set, so this is 1 day's worth of MODIS data. What I'm going to do now is I'm going to zoom into a place that I'm familiar with, which is the Survey Territory, again, in Rondonia, like that. So you can double click to zoom in. You can also use this zoom slider, and it's very similar to Google Earth. And now I'm going to look at some old imagery. So one thing is you can turn the layer on and off. So here you have all the layers that you're looking at. You can look at multiple layers. You can turn it on or off by clicking on the eye. And then if you want, you can look at the satellite imagery from Google Earth, or you can look at sort of a Google map. This satellite imagery is from all different times. This is the kind of thing that you see in Google Earth. So it's different satellites, usually very high resolution, and from all different times. So it's not necessarily today's data. But this is a 16-day mosaic over these dates. So when you click on this layer, you get this little window that lets you set the time we were looking at. So what I'm going to do is I'm going to go back in time and look at an old version. So you can do that by clicking here, and now that's looking at sort of more the summer. Or if you want to go very far back in time, you can jump to date, change the year here. So let's look at 2000. Let's look at May. Oops. Yeah. That doesn't go back that far. Okay, May 16. There we go. So this is data from 2000, and I can save it. Oops, go back. There you are. Let's zoom in a little bit more. One thing to note is sometimes, if I zoom out, some MODIS, for instance, if it's very cloudy, there's no data here. So here you can see the MODIS data, here is the satellite data, and you can tell where it's satellite, where it's data versus no data by kind of clicking back and forth. So if you look at the map, you can see there's no MODIS data here, and that's just because it was very cloudy during this period of time, and they just couldn't get any good data during that point. Luckily, I'm not looking at that area, I'm looking at something where there is data. All right, let me zoom out. And now I'm going to add another layer. So this is a little bit funny, I'm going to add in the same thing again. So the same data set, this adjusted 16-day MODIS. And instead of looking at the data page, I'm just going to click on Open in Workspace, and it directly opens. The new one is opened up on top. And so now I can kind of flip back and forth and see what changes happened. So, look at this. This is what we were looking at before lunch. That's now, and that's 2000 in the year 2000, right? So this is a quick way to do some just sort of change detection. Does it look good? Yeah. Yeah? Okay, so let's go through it together. Let's do it this way. This is always, there we go. All right, so the first step is to open a browser. It works well in Chrome. It works on iPads. Works in IE. Doesn't work so well in Firefox. But if you have Chrome, that's a good one. So go to this address, earthenGen.google.org. Everyone there? Okay. And click on the Data Catalog button. Okay. And at every point, if you hit the snag, please raise your hand, and someone will come over. That will bring you to this page. So please click on the description of that data set, MODIS, the RDF adjusted 16-day mosaic. And you should get this. Everyone good? Then you can click on that to open it up in your workspace. And you should get this. So I'll pause here because it might take a little bit for it to load on everybody's site. Looks like people are getting it. All right. So you can play with clicking the eyeball on and off to turn the the layer on and off. And zoom in someplace. You don't have to necessarily look at Rondonia. You can look at any place that you're interested in. So if you're interested in someplace in India, feel free to look to go to India. It would help to click the map button on and off to see where there's data, because it's kind of hard to see in satellite view. But so there's no data here. Sorry if you're just in the DRC. But if you're interested in Madagascar, there's data. So zoom into someplace you like. And once you're there, click on this to get the time window up. And choose a time that you're interested in, sometime in the past. So remember, this satellite, we don't have data for the year 2000. So try to stay after 2000. Everyone good? So once you've chosen the dates, save. Oh, so one thing that's a little tricky is if you're using this date tool, you have to actually click on a day, right? So if you choose a year or you choose a month, you still have to click on a day to close it up. And you get that thing by clicking on jump to date. Okay. So save. And so now it's zoomed in. Switching.
You know, stop that.
Let me try. Let's see.
Stop before you stop now.
Yeah, I'm afraid that's gonna go back once I switch back. Yeah. Let's see. Yeah. All right.
Is PowerPoint doing it or something?
I think it's something with the resolution. Okay, so once you found someplace you like, click back on the data category.